everybody, it's Miss Phoebus, and I'm back with actually two lessons. We're going to do two lessons in one. We're going to do lesson 9 and 10. We're going to smack them together because they pretty much go together. So we're going to cut it down by only doing, I think I'm only going to do the odd problems. So there's going to be some things about you try in there and things like that, but we're only going to do the odds. If you find that you need more than the odds, let me know, and I will give you a link to the video that has the odds and the evens as well. But pretty much if you understand how to break down absolute value equations, then absolute value inequalities are going to be very, very similar. You just have to get the graphs on the graphs of the answers on there, and that is just a compound inequality graph. So this lesson is not going to be on test 1, but it will be on test 2. So it is something that you may need to go a little bit more in depth with. I didn't want to change the numbering system that I had for my lessons because then it'll affect all the other ones after it. And so that's why we're still calling this lesson 9 and lesson 10. But that's kind of what's going on there. So let's go ahead and get into lesson 9, which is solving absolute value equations. One of the questions I have for you is, what does absolute value even mean? Well, absolute value is the distance a number is from 0 on the number line. So the absolute value bars, those vertical bars, represent absolute value. Be very careful. Sometimes people think that they're ones, so just watch out for that. But the absolute value of 6 is 6. How far is 6 away from 0? 6 units away. And the absolute value of -6 is also 6. How far is -6 away from 0? Well, it's 6 units away. So it's a distance thing, and distance is never considered really negative. So that's what we're talking about when we talk about the absolute value. We're talking distance from 0. So your learning goal for this lesson, for this part of this lesson, is I can solve absolute value equations justifying each step when necessary. And here's our standards. You have to be able to explain a step in solving an equation, and the state wants to make sure that absolute values are ones that you can explain. So here we go, the steps for solving an absolute value equation. Step 1. Isolate the absolute value. This may require a few steps. Step 2, check to see if the absolute value equals a negative number. If it does, then your answer is no solution. At this point, it's going to be okay if you forget to check to see if it equals a negative number. If you check at the very, very end, you will be able to catch any no solutions. Step 3, you're going to break the equation into 2 pieces. This is the only way that you can undo absolute value bars. So one equation will look pretty much unchanged. The other equation gets a set of parentheses with a negative out in front. Step 4, you're going to solve both equations separately. Step 5, and here's where if you didn't do step 2, then you should be able to check your solution and find that you have a no solution kind of situation. It is very, 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 very important that you never, ever, never, ever, 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 never, never, ever distribute across the absolute value symbols. So do not distribute. I know you've been trained, you see parentheses, you're ready to distribute, lickety split, but you are not allowed to ever distribute across absolute value. And if I catch you doing it, you're going to lose points. But more so, you're almost always going to get the wrong answer. You may feel like you're getting the right answer, or I should say answers, because you're going to be getting more than one. But if you are distributing, it's probably going to end up getting you something that's incorrect. So I don't want that to happen, and so we're going to practice not distributing. I'm going to show you how to handle that. All right, so here we go. We're working the odds, although I'm tempted to do number 2. So I might do 1 and 2, but we'll start with the odds after that. So number 1 is very straightforward. All I have is a variable inside absolute value bars, and it equals a number. So you usually get to this very easy situation pretty quickly in some cases. So you don't have to do a whole lot. So do I have to, I check, does it equal a negative number? No, it doesn't. I'm going to break this up into two, and I draw the arrows just to remind me that there's two, and I find that that's helpful. As I do this and I break it up into two, I no longer need the absolute value bars. So I lose my absolute value bars. And the first one looks pretty much unchanged. Other than I've lost my absolute value bars, everything else is the same. The other equation that I have to write is it's got a negative in front of a set of parentheses. And those parentheses are around what was inside my variable. This I'm going to, or what was inside my absolute value bars. This I have to solve by dividing. And so n equals -7. So the idea is that I'm going to split the two. I have to learn about this whole negative with the set of parentheses and then solve both of the equations for n, and I get two answers. Now, don't fall into the trap that just because one of them is 7, the other one always has to be -7. They don't necessarily have to be opposites. In some cases, they are. So let's check. So I'm going to plug in 7. Is the absolute value of 7, 7? Yes, it is. Is the absolute value of -7, 7? Yes, it is. So this is my check. Am I going to require you to check? No. Am I going to, when I look at your answers and they're not right, am I going to know that you didn't check? Yes. So a check is always at least a quick check, just looking to see if plugging that value in makes sense. A quick check is recommended. Again, it'll help you if you are in this no solution kind of territory. Let's look at number 2. So number 1, we already have the absolute value isolated. Number 2, the absolute value is not isolated on the left side. I have that -5. I have to move the -5 first before I do my split into 2. So if I don't do that move, I'm going to possibly end up with an incorrect answer or 2. So you have to isolate by adding 5 to both sides. That means the absolute value of P is 14. And then I can split it up and have P equals 14, and then the negative parentheses P equals 14, and then solve for P. Now, you may be like, well, Miss Phoebus, why are the parentheses there? Why are you putting this negative in front? You know, that kind of thing. Well, the negative in front, we have a positive assumption and a negative assumption. So here's our negative assumption. Okay, so again, let's look at assumption. Let's look at this problem over here where we were looking at the check. There are 2 values that I can plug into an absolute value to have it equal a positive number. One of them is going to be a positive, and one of them is going to be a negative. So I'm looking at this positive assumption. Well, what happens if I'm looking for the positive number? What am I going to get? And in this case, 14. And what am I going to get when I'm trying to figure out, well, what negative number can I plug in? And in this case, it's -14. So that's why we always break it up into 2, because we have to figure out, well, what if it's positive inside the absolute value? What if it's negative inside the absolute value? Right now, the parentheses aren't doing a whole lot, but when I get more than one thing, so if I've got like P plus 5 inside the absolute value, it's going to allow me to do the distributive property and get the right answer. Let's do a quick check. Is the absolute value of 14, which is 14, minus 5, does that equal 9? Yes, it does. And the absolute value of -14 minus 5, well, absolute value of -14 is 14. 14 minus 5, does that equal 9? Yes, it does. So we are checking to make sure that we're getting the right answer. But remember, these are our final answers. The check is not the final answer. All right, now we're going to go and stick with odd problems. Remember, if you want evens, let me know and I'll link you to the full video. All right, so let's look at number 3. So do you see how we have our absolute value? It's already isolated. There's nothing on that side, so we're looking good there. And if you didn't notice, we do have this equaling a negative number. So this is a positive number, right? Because our absolute value is always going to generate a positive number, right? What's the absolute value of negative 2? 2. What's the absolute value of positive 2? 2. There's no way for me to plug something inside a set of absolute values and have it give me a negative number back out. So this is asking the question, when does a positive number equal a negative number? It never does. So that's where we say no solution. But let's say for just a second, just a moment, you didn't realize that. You didn't even check to see if it equals a negative number. You're like, woo, I'm ready to split into 2. Let's see what happens there. So that would mean I would have W equals negative 13 and then negative W equals negative 13. And then here I would divide by negative 1, and so I would get W equals 13. And you would still get 2 answers. You probably are feeling pretty good about yourself, but this is where the check will help you. So if you do the check, and you go back over here and you go, okay, absolute value of negative 13 equals negative 13. That's not right, because the absolute value of negative 13 should be 13. 13 does not equal negative 13, so you got to throw it out. Same goes for absolute value of 13. Does that equal negative 13? No. The absolute value of 13 is 13. 13 does not equal negative 13. I should put not equals in there. We have both answers being thrown out. That means that we have no solution. Now, if you can identify this way up here, you just saved yourself a whole lot of work. And you don't have to do that middle piece that I just skipped with the W's and the negative ones and all of that stuff, okay? So it's something to watch out for. It helps maybe with a speedier solution, but isn't necessarily something that you have to be able to identify. If you have the check going along with it, then you're going to be able to catch that no solution. All right, so here we're going to look at number 5. Now, number 5, the absolute value bars are all by themselves. So there's no isolating anything. It's already isolated. But if you notice, I've got a 2t and a plus 3 inside. So I've got 2 terms, and I'm going to have to deal with that as I split them up. There's no removing something from the absolute value from inside. It's kind of stuck there until I split it up. So I end up with 2t plus 3 equals 5, and then here's where the parentheses are very, very helpful and actually necessary. And we're going to have negative parentheses 2t plus 3 equals 5. And then we're going to solve each one separately. So over here I'm going to subtract 3. 2t equals 2, and we'll divide by 2. So t equals 1. And usually at this point in class I'm like, okay, we're going to make a prediction. I can ask you what you predict, but I can't tell what you're saying because this is a video. Surprise! And so at this point I usually say, okay, how many of you think the other answer is t equals negative 1? And so we count hands and we look and all of that stuff. And so let's see if we get t equals negative 1. Let's distribute this negative. So that means we've got negative 2t minus 3 equals 5. We're going to add 3 to both sides. Getting over in the other section of work, but that's okay. And then I'm going to divide by negative 2, and guess what? It's not negative 1, it's negative 4. Okay, so I have 2 answers, and just because one of them is positive 1 does not mean that the other one is automatically negative 1. You can't fall for that. Don't go there. You're looking for a shortcut that doesn't exist at that point, okay? So we're trying to figure out what numbers plug in. Let's check and see if we're right. So 2 times 1 plus 3. Well, 2 times 1 is 2. 2 plus 3 is 5. The absolute value of 5 is 5. Yep, we're looking good. Okay, so 2 times negative 4, that's negative 8. Negative 8 plus 3 is negative 5. Is the absolute value of negative 5, 5? Oh yeah, we found them. We found both of them. There's two answers. Now don't think that you can just give me one and not give me the other one and you're going to get all your points. Okay? These absolute values are almost always, I say almost always, because we have this positive and negative, right? We should get two answers. But if it equals 0, there's no positive 0 and negative 0, right? So you might get one answer, but that's like a special case right there. Special case. All right, so that's number 5. Let's see what we can do with number 7. All right. I know it says you try. We're going to do it together. But 8 does look a little, I might want to do 8. I don't know. We'll see. All right, number 7. We're going to split this up into 2 because the absolute values are isolated. I forgot that part. So we're going to split it up into 2. Negative 3f plus 4 equals 5. And then over here we need a negative in front of our negative 3f plus 4 equals 5. All right, we're going to solve. So I'm going to subtract 4. So negative 3f equals 1. Divide by negative 3. So f equals negative 1/3. And then for the other one, I'm going to distribute, let's switch colors, distribute this negative. We're multiplying by negative 1 inside those parentheses. Make sure you get both numbers. It's going to be a positive 3f minus 4 equals 5. We're going to add 4 to both sides. 3f equals 9. We're going to divide by 3, so f is 3. And we get two answers. Now, we should check, and in checking, we should get the right answer. However, if we make an algebraic move somewhere in here that is wrong, and we get the wrong answer, and we check it, and it doesn't work, we're going to throw it out. And we're going to think that it's no solution. So you have to be very careful in the work that you're doing and not think that 5 plus 4 is 20 or something like that and do some random operation that isn't required and end up with the wrong answer, because then you're going to think, well, none of them work. Everything's no solution. So pay very close attention. You're really paying attention to detail to make sure that you're getting and arriving at those answers, and then checking to make sure that you're right. If you're starting to check stuff and everything's not working, you might want to go back and look at it just a little bit closer. All right, so we're going to look at this problem. Caleb is solving for the following equation for x, provided justification. Oh, we're going to go back. Go back. Okay, I wanted to look at 8. So let's look at 8. We need to work on isolating this absolute value. That's what I wanted to spend a little bit of time on, because then the splitting up is the same stuff. So when you isolate this absolute value, I really want you to almost think of this like absolute value of c minus 2 like an extra variable. A different variable, but an extra variable. And if you were going to solve this for this x, wouldn't you add 10? And then end up later on dividing by that 3. So it's the same idea. We do not want to distribute the 3, but we need to move this negative 10 by adding 10. Do not distribute. Don't you do it. I know you want to. Don't you do it. But divide instead. Okay, and then what that's going to allow you to do is to get rid of that 3 and not have distributed. Equals 7, and now you're ready to break it up. And get your parentheses in there, and then you're ready to go, and you keep going, right? Solve for C. Okay, but pay very close attention, because this is going to be on test 2, where you have a piece being added or subtracted, and a piece being multiplied, and how are you going to remove those and then be able to split up? So don't start distributing. Don't do it. It's not going to work out. All right, now let's look at number 9. Caleb is solving the following equation for x, provided justification for each of Caleb's solution processes. So we know we have given here. Looks like we went from having a 2 and a 10 down to a 5, so that means that they probably divided by 2 on both sides. Do you remember what that's called? The division property of equality. All right, and then, oh, look here. Here we have the split. right? So there's not really an official name for it. Maybe there is, but I don't know what it is. But we're going to say break into two equations to basically get rid of that absolute value. Okay, now they did something different here, and this is something that you can do. I've taught this multiple ways. However, there are two ways to do it. The parentheses and the negative is the way that I've had the most success with. But sometimes, if you notice, this piece and this piece and this piece, they all match, right? The negative ended up over here. So if that's a better way for you to process and keep all the stuff with the 3x minus 7 the same, we have here be our positive assumption, and this negative 5 indicate the negative assumption. So you can do that. When you do it that way, the nice thing is that whatever choice you make for the left equation is going to be the same choice that you make for the right equation. So that's going to be the addition property of equality. Make sure you have your property of equalities there. And then in the next move, they divided by 3, and that would be the division property of equality. So you can still use your property of equalities. This guy, we don't have a special name for him, but we'd come up with something. But the other ones have standard names, so you need to be using those. Okay, so that's going to end a lesson 9. We're going to go ahead and jump into lesson 10. Oh, come on, maybe. There we go. Okay, so lesson 10, solving absolute value inequalities, very, very similar. And you are going to solve and graph, and you're going to pay very close attention to whether you have a no solution or an infinitely many solutions. So you could have either of them happening with the absolute value inequalities. Only with the equations, we just had the no solution component. All right, so we're still in the same standard. And things to know about absolute value inequalities. So this is similar to using your absolute value equations with a few differences, like you're going to graph, and you can graph with the equations, but they're kind of boring. The inequalities are a little bit more interesting, and usually what they tend to have you graph. Absolute values will always be larger than a negative number. So the solution will be either infinitely many solutions, or we're going to start also talking about infinitely many solutions, and all real numbers mean the same thing. So you can use those interchangeably. Absolute values will never be smaller than a negative number. So if you do notice that you've got negative numbers, you need to pay attention to the signs. So they're always going to be larger than negative numbers and never be smaller than a negative number. If it's smaller than a negative number, it's going to be no solution. If you multiply or divide by a negative number, remember, it's the golden rule of inequalities. You've got to flip that inequality symbol and check and graph your solutions. It's very, very important that you never, ever, ever, never, ever, 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 never, never, never distribute across the absolute value bars. Don't do it. I know you want to. Don't do it. Don't do it. All right, we're going to do problem number 1. Our absolute value bars are by themselves, so we don't have to isolate. We have a positive 5, so we don't have to worry about any negatives, so we're ready to split this up. So we've got x over 6 is greater than or equal to 5, and then I'm going to have my negative x over 6, and guess what, guys? This should feel just like solving an equation. All right, how do we get rid of divide by 6? We multiply both sides by 6. 6, divide by 6, cancel, leaving behind x is greater than or equal to 30. Over here on the other side, I'm going to multiply by 6, but also to get rid of that negative, I'm going to multiply by negative 6 on both sides, so that the divide by 6 and the multiply by 6 cancel, and my negatives cancel as well. So x is, now hang on a second, ooh, did you see I multiplied by a negative number? I have to flip that inequality around so that I can get that shading right. All right, so remember, just because one's positive 30 doesn't necessarily mean that it's always going to be negative 30 on the other one. It just happened to work this time. Okay, so two numbers on the number line, negative 30 goes on the left, positive 30 goes on the right. This is going to be very similar to a compound inequality. Actually, it is. It's going to either be and overlap or and not overlap. So let's see what we have. At 30, I have a closed circle because there's an equal to bar, and I'm going to shade to the right. At negative 30, I've got a closed circle because there's an equal to bar, and I'm going to shade to the left. Ooh, it's an or compound inequality. And that's what the graphs are going to look like for your absolute value. All right, we're going to skip number 2. We're going to go work on number 3. So here we go, number 3. The absolute value bars are already isolated, so we're going to split this in 2. We're going to have x plus 5 is less than 9. We're going to have parentheses with negative in front of them. And then we're going to work on distributing. So, or over there, I'm going to work on subtracting. X is less than 4. Here I'm going to distribute, multiply by negative 1. So I'm going to have negative x minus 5 is less than 9. I'm going to add 5 to both sides. So I get negative x is less than 14. Divide by negative 1. Be careful, we're dividing by negative. So x, we have to flip the sign around. X is greater than negative 14. All right, so number line, negative 14 goes on the left because it's smaller. 4 goes on the right because it's larger. Do you see we have open circles, no equal to bars? And then less than 4 lives this way to the left. Greater than negative 14 lives that way to the right. It's everything in between. This is an and compound inequality. There you go. There's number 3. All right, let's look at number 5. Here are my absolute value bars. Oh, but they're not isolated. I have a 10, a plus 10 that I need to get rid of. So how do I move that plus 10? I subtract 10 on both sides. So then I've got the absolute value of b minus 8 is greater than 12. Now my absolute value bars are by themselves, so I can break them up. And I've got b minus 8 is greater than 12. Get my negative in my parentheses. And then we solve. So I'm going to add 8. So b is greater than 20. And then don't forget to distribute. And then I've got negative b plus 8 is greater than 12. I'm going to subtract 8. Negative b is greater than 4. Dividing by negative 1, watch out. We've got to flip that inequality symbol. B is less than negative 4. Negative 4 goes on the left because it's smaller. 20 goes on the right because it's larger. Ooh, they both have open circles. B is greater than 20. That's to the right. B is less than negative 4. That's to the left. This is an or compound inequality. All right, let's see what we got next. Ooh, number 7. All right, now it says you try, and if you want to pause it and see if you can do these problems, awesome. We're going to go ahead and work out number 7, and I'm going to look at, ooh, here's my absolute value bars. I got to isolate them. I have to move that 9. I'm going to add 9 to both sides. So n over 3 is less than 21, and now I can split. Don't split until you get the absolute value bar. Those bars by themselves. N over 3, I need some parentheses with the negative, and there we go. And we're going to multiply both sides by 3. N is less than 36. And then I'm going to multiply both sides here by negative 3 to take care of the 3's and the negatives, but I have to flip that inequality and get a negative 36. Negative 36 on the left, positive 36 on the right. Open circles. We're greater than 36. We're also less than negative 36. This is an OR compound inequality. All right, I do want to look at number 8. It is kind of special, so let's give it a little attention. Absolute value bars are by them. Oh, they're not by themselves. I gotta move that negative 10. Add 10 to both sides. Now, at this point, you should notice we've got a negative number on the other side of that inequality symbol, away from that absolute value. So this is going to be a special solution. Okay? If you don't catch it right now, it may be harder to catch later on down the line. So let's look at what this actually means. So remember, our absolute value is always going to be a positive number. When will a positive number be less than a negative number? Never, right? So this is no solution. Well, what does the graph of a no solution look like? Well, you got to put something on the graph, right? But it's a blank line. So that is, if you have to graph no solution, that's what it's going to look like. Now let's pretend for just a moment, we're going to pretend that the original problem had a greater than inside it. So this would mean that a positive number would be greater than a negative number, and that's always true, isn't it? Positive numbers are always bigger than negative numbers, so we would say infinitely many solutions, or you can say all real numbers. That's just another thing, means the same thing, and these are my favorite because I love shading, so all real numbers shade the whole number line from end to end, okay? So that means all the numbers are answers. So that's going to be difficult to check because all the numbers are answers. No solution, you may feel like, like if we're picking numbers to check, we're picking numbers to plug in. So you can plug in what's a number less than, 63. You plug in negative 70. Is it going to work? Is it true? And so you're plugging things in for variables to see if it's true. Well, if it's all real numbers, you might not realize it because, being greater than 36, that's a lot of numbers, right? So are you going to check every single one of them? It's probably not happening. So what you really need to have like an open eye, you're really watching out for when do those negatives pop up on the other side of the inequality symbol, and that's when your absolute values are being isolated. If that negative pops up, it's a special solution. All right, let's work on number 9, and I think that's going to be the last one for today. I'll double check that though. So number 9, we are going to isolate our absolute value. You cannot distribute that 4, don't you do it. If you are going to choose to divide by 4, you're going to have to divide by 4 here, here, and here. I personally don't recommend doing that, but some people do, and then they don't divide that 8, and then they get the wrong answer. So if you are going to divide, go ahead and you have to divide everything. I like to subtract first, and that's what I recommend you do. 24 minus 8 is 16. Now divide both sides by 4. Don't you dare distribute that 4. Make me cry. Don't you do that. Absolute value of 6 minus 2a is less than or equal to 4. I did not divide by a negative, so we're good there. We're going to split her up. 6 minus 2a is less than or equal to 4. And here's my negative. And now we're going to solve. So I'm going to subtract. I have negative 2a is less than or equal to negative 2. I'm dividing by a negative. So I've got to flip that inequality around. Over here, I'm going to distribute my negative. I'm going to add 6. 2a is less than or equal to 10. Divide by 2. A is less than or equal to 5. And then 1's on the left. 5's on the right. Close circles for both. We're greater than 1. We're less than 5. We're shading everybody in between. All right, so that's it for lessons 9 and 10. If you need some extra problems, you want to talk about something, let me know. And we will see how this goes in the homework. All right, I'll see you guys in the next video. Bye!